Okay, let's look at doing uh, learning how to do trends for ions. And so, like uh, we had for I, uh, uh, electronegativity, ionization energy, atomic radius, there are some trends. But with ions, it's kind of hard to look at the specific trend on the whole periodic table. So you could look at going down. It's kind of obvious that every time you go down, the ions do get larger. But going across a period, they tend to get larger from left to right. But there's a difference between the metals and the nonmetals. And it has to do with metals lose electrons and nonmetals tend to gain them. So it's kind of hard with the period trying to draw out just like one line all the way across the periodic table. So instead of looking like at the periodic table for the trend as a whole, we're going to look at specific cases. And so the first rule that I want to kind of show you is that metal ions are always smaller than the atom from which they were formed because they lose electrons. Let's look at an example here. So here we have lithium, and the lithium, the neutral atom, it has 3 protons and 3 electrons. So if you write the electron configuration for that, it's 1s2, 2s1. It has 2 layers or shells of electrons. But let's look at what happens with lithium, the ion. Okay, remember metals are losers. They lose electrons. So here's lithium plus 1. It does have 3 protons. Protons don't change. But it lost 1 electron. And so then it becomes 1s2, not 2s1. I wrote it here because I wanted to show you when it becomes an ion, it loses that electron. So it just becomes 1s2. So now look what happens. Because it just becomes 1s2, let's look at what happens. From the atom, when it loses that electron, the radius tends to shrink. All right, it does shrink because you're losing a whole layer of electrons. Okay, so now, as you can see, this one has 2 shells of electrons or 2 energy levels of electrons, whereas lithium, the ion, only has 1. So metal ions are always smaller because they lose electrons. Okay, let's look at nonmetals. Okay, remember nonmetals, they gain electrons. So nonmetal ions are always larger than the atom from which they were formed because they gain electrons. So let's compare nitrogen, the neutral atom, versus nitrogen, the ion. So nitrogen, the neutral atom, has 7 protons, 7 electrons. So if we write the electron configuration, it would be 1s2, 2s2, 2p3. But nitrogen, the ion, it has 7 protons and 10 electrons. And so if we were to write its electron configuration, it would be 1s2, 2s2, but we have to add 3 electrons, so it's 2p6. So by putting these electrons in this energy level, it makes it expand a little bit. The energy level doesn't really grow bigger, I guess, but the electrons would exist further away from the nucleus. So nonmetal ions are always larger from the atom from which they were formed. Now, what you might have to do on a test is something like this. It might say, which has the larger ionic radius? Beryllium 2 positive versus oxygen 2 negative. First, write the electron configurations for the ions. So I'm going to write those out here. So here's beryllium. So beryllium would be 1s2, 2s2, but when it becomes the ion, beryllium 2 plus, it would just become, it's going to lose 2. It's a metal, it's a loser. It's going to become just 1s2. So if you were to draw it, it has 2 protons and it has 1 energy level, just the 1s2 with 2 electrons. That's what beryllium 2 plus. So a big tip here is to, after you write the electron configurations, draw a picture. That will really help you. Now let's look at oxygen. Oxygen, when it's neutral, is 1s2, 2s2, 2p4. But when it becomes an ion, oxygen 2 minus, it's 1s2, 2s2, 2p6. So oxygen didn't lose an energy level filled with electrons. It actually just added a couple more. So now you can see beryllium has one energy level, beryllium 2 plus, the ion, has one energy level with 2 electrons, while oxygen 2 minus has 2 energy levels with way more electrons. Therefore, oxygen 2 minus is way larger than beryllium 2 plus. All right, let's look at one more case. All right, which has the larger ionic radius? We have nitrogen 3 minus and fluorine 1 minus. So the first thing that you should do is write the electron configurations, which I've already did here. So nitrogen 3 minus is 1s2, 2s2, 2p6, and fluoride 1 minus is 1s2, 2s2, 2p6. Nitrogen gained 3 electrons, fluorine gained 1, but they have the same identical electron configuration. So what's going to determine the radius? Okay, well, they have the same number of shells of electrons and the same number of electrons in the shells. All right, so that's not a factor, but what is a factor is the nucleus. Nitrogen has 7 positive charges because it has 7 protons in the nucleus pulling on these electrons. Fluorine has 9 positive charges pulling on the same number of electrons. So because they have the same shells and the same number of electrons, the nucleus, that's the stronger nucleus, is going to have the smaller radius. So because fluorine has 9 protons, it's fluoride, I guess, not fluorine, it's going to have a smaller radius. Okay, so I guess which one has the larger radius? It would be nitrogen because it has fewer protons pulling on the same number of electrons that fluorine has. Okay? Fluorine is going to shrink its electrons closer or pull them in closer because it has more protons pulling on those electrons. That's it.